So I'm interested in the interaction of platelets and tumor cells. Platelets support tumor cells in nearly every step of forming metastasis. So in this term, platelet cancer cell interaction, I use single cell flow spectroscopy to quantify the interaction of platelets and tumor cells and to quantify the effect of, let's say, anti-metastatic drugs. So the actual view of the situation is that platelets form a kind of invisible cloak around the circulating tumor cell, but we never observe this. When we scan platelet tumor cell aggregates, what we see is platelets, small platelets or rest of small platelets on top of tumor cells, and with peak force tapping or fast tapping mode, we could observe that there is a kind of uptake of platelets into tumor cells. We think it's more likely that the tumor cell uses platelet proteins after an uptake of platelet to adhere to the vessel wall and also to escape the immune surveillance. And additionally, it's known that platelets and also platelet-derived microparticles contain mRNA, and this changes the proteome of the tumor cell. What I now try to do is to use peak force QNM to see a mechanical pattern on the tumor cell after interaction with a platelet. And yeah, I saw something, but it's not finished yet, the project. It looks like that there's a kind of footsteps where the tumor cell gobbles up the platelets. There is change in elasticity, viscosity change in the platelet membrane, in the tumor cell membrane, and that may give us some hints according to the mechanism how the tumor cell incorporates the platelet. The real interesting stuff was last year's coming up with peak force QNM, a technique where we could get several channels, several modes in one scan process, like elasticity, like dissipation, like adhesion, and so on. That enables to observe dynamical changes of a cell or layer of cells in acceptable time, and you have 8 different channels where you could see what happens. So maybe you didn't see much in a topographic channel, but you could see a lot in the elastic modulus channel or in adhesion channel or even dissipation channel. So this is a real improvement.